Math creates reality, not describes it, creates it. I know that sounds backwards. You think math is a tool we invented to describe the universe. Equations, numbers, geometry, all human constructions we use to model what's out there. But what if that's completely wrong? What if math isn't describing reality? What if math is reality? What if the universe is mathematical at its core, and everything you experience, matter, energy, space, time, consciousness, are just manifestations of mathematical structures? I'm Leonard Susskind. I've spent 50 years in theoretical physics, and the deeper we go, the clearer it becomes. Math isn't the map. Math is the territory. This isn't philosophy. This is what physics keeps showing us. Every time we discover something fundamental, it's mathematical. Not approximately mathematical. Exactly mathematical. Particles are representations of symmetry groups. Forces are gauge fields. Space-time is a pseudo-Riemannian manifold. These aren't just descriptions. These are what these things are. The math is the reality. Let's start with something basic. What is an electron? You probably think it's a tiny particle, a little ball of charge. But that's wrong. An electron is not a thing. It's a quantum of the electron field. And what is the electron field? It's a solution to the Dirac equation, a mathematical structure. The electron doesn't have mathematics. The electron is mathematics. The mass, the charge, the spin, all these properties are parameters in equations. Change the math, you change the electron. The math comes first. Here's what bothers people. They say math is abstract. How can abstract things create concrete reality? But that distinction is wrong. What you call concrete, solid matter is already abstract. Touch a table, feels solid, but it's mostly empty space. Atoms are tiny nuclei with electrons in clouds around them. The nucleus is quarks held by gluons. Quarks and gluons are excitations of quantum fields. Fields are mathematical objects, solutions to equations. At every level, when you dig deeper, you find mathematics. There's no point where you hit something that isn't math. Einstein understood this. General relativity doesn't say gravity is like curved spacetime. It says gravity is curved spacetime. The Einstein field equations don't describe how matter curves space. They define what spacetime curvature is. The metric tensor, the Ricci curvature, the stress-energy tensor, these mathematical objects are the physical reality. There's nothing underneath the math. The math is what exists. Quantum mechanics makes this even clearer. In quantum theory, the state of a system is a vector in Hilbert space, not a representation of the state. The wave function is the reality. When you measure, you're not discovering pre-existing properties. You're projecting the quantum state onto measurement eigenstates. The mathematics of measurement determines what you observe. Reality is the mathematical structure of quantum states evolving according to the Schrödinger equation. Let me tell you about symmetry, because this is where math's power becomes undeniable. Every force in nature comes from symmetry. Electromagnetism comes from U-gauge symmetry. The weak force from SU, the strong force from SU. These aren't just patterns we noticed. The symmetries generate the forces. You can derive Maxwell's equations, all of electromagnetism, just from demanding U-gauge invariance. The math creates the physics, not the other way around. Noether's theorem makes this explicit. Every continuous symmetry corresponds to a conservation law. Symmetry under time translation gives energy conservation. Symmetry under space translation gives momentum conservation. Rotational symmetry gives angular momentum conservation. These conservation laws, the most fundamental facts about reality, are mathematical consequences of symmetries. The universe conserves energy because the laws of physics are time symmetric. The math determines what must be conserved. Here's where it gets strange. The standard model of particle physics, our best theory of matter, is completely determined by a symmetry group, SU times SU times U. Once you specify this mathematical structure and add a few parameters, masses and coupling constants, you get all particles, all forces except gravity. Electrons, quarks, photons, gluons, W and Z bosons, the Higgs, everything emerges from the mathematics of this symmetry group. The particles aren't fundamental. The math is. String theory goes further. In string theory, particles aren't fundamental either. They're vibration modes of strings. But strings aren't little physical objects. Strings are mathematical, one-dimensional objects in an abstract space. Different vibration patterns correspond to different particles. An electron is one vibration mode. A quark is another. Photons, gravitons, all particles are notes in a cosmic mathematical symphony. The music is math. Reality is what the math sounds like. And here's the thing about string theory. It requires extra dimensions, 9 or 10 spatial dimensions for consistency. We only see 3. Where are the others? Compactified, curled up small. But the shape they're curled into, the geometry of these hidden dimensions, determines what particles and forces we observe. Change the geometry, you change physics. Different Calabi-Yau manifolds, different universes. The geometry, pure mathematics, creates the physical laws. Let me tell you about the unreasonable effectiveness of mathematics. Eugene Wigner wrote about this. Why does math work so well in physics? We write equations on paper, abstract symbols, and they predict reality with stunning precision. General relativity, quantum mechanics, electromagnetism, all described by math that works to incredible accuracy. This seems miraculous if math is just a human invention. But it's not miraculous if math is reality. Of course, math works. Math is what's really there. Consider complex numbers. Imaginary numbers. Square root of -1. Seems completely abstract, a mathematical trick. But quantum mechanics requires complex numbers. The wave function is complex valued. You cannot formulate quantum theory with real numbers alone. Reality is fundamentally complex in the mathematical sense. The universe uses imaginary numbers, not as pools, as building blocks. Or consider infinity. Infinite dimensional Hilbert spaces in quantum field theory. Infinite sums in path integrals. Infinities in perturbation theory that we remove through renormalization. These infinities aren't problems with our math. They're features of reality. The universe is mathematically infinite in structure. We struggle with infinities because we're trying to work with the actual mathematical fabric of reality. Here's something that keeps me up at night. The holographic principle says our universe is a hologram. All information a volume encodes on its boundary. A 2D surface contains all data for 3D space. This is deeply mathematical. Information, theory, entropy, degrees of freedom, all mathematical concepts. And they determine space-time structure. Space isn't fundamental. Information is. And information is mathematical. Bits, qubits, entanglement entropy, these mathematical objects generate space itself. In ADS-CFT, we see this explicitly. Anti-de Sitter space, a 4D spacetime with gravity, emerges from conformal field theory on a 3D boundary. The boundary theory is purely mathematical. Quantum fields, correlation functions, no gravity, no space in the usual sense. But from the mathematics of this boundary theory, space-time emerges. Space, gravity, black holes, all derive from boundary theory math. Math creates space. Let me tell you why this matters for the nature of existence. If reality is mathematical, then existence is mathematical existence. What does it mean for a mathematical structure to exist? It means it's consistent, logically coherent. The universe exists because the mathematical structure describing it is self-consistent. There's no need for something to instantiate the math. The math is enough. Mathematical existence is the only existence. This is the mathematical universe hypothesis, proposed by Max Tegmark. The universe is a mathematical structure, not a universe with some mathematical properties. The universe is mathematics, and not just our universe. Every consistent mathematical structure exists. Every possible universe, every set of physical laws that can be written consistently, exists in the same sense our universe does. We're one mathematical structure among many. You might object. You experience qualia, redness, pain, joy. That's not mathematics. But maybe it is. Maybe consciousness is what certain mathematical structures feel like from the inside. When information processes in specific patterns, when integrated information reaches certain complexity, subjective experience emerges. And integrated information is mathematical. Phi, the measure of consciousness in integrated information theory, is computed from the structure of causal relationships. Math again. Here's the problem people have. They think math is in minds, not in reality. Humans invented numbers, geometry, calculus. Math is our creation. But that's backwards. We discovered math. Mathematical truths exist independent of us. 2 plus 2 equaled 4 before humans existed. The Pythagorean theorem was true before Pythagoras. Pi had the same value. Mathematical structures exist in a Platonic realm, independent of physical reality, independent of minds. But if mathematical structures exist independently, and physical reality is a mathematical structure, then physical reality exists in the same way math exists. Not as something separate that math describes. Physical reality is one particular mathematical structure, the one we inhabit. Other mathematical structures are other possible universes. The landscape of mathematics is the landscape of all possible realities. Let me give you an example. The laws of physics in our universe include quantum mechanics, relativity, gauge symmetries. These can be written as mathematical equations, but the equations have solutions, many solutions. Each solution is a possible state of the universe. Our universe is one solution. Other solutions are other universes, possibly with different constants, different particles, different laws. All these solutions exist mathematically, and mathematical existence might be the only existence. Here's where causation breaks down. Normally, we think causes precede effects. But if reality is mathematics, causation is just correlation within the mathematical structure. The equations relate different parts of the structure. What we call cause and effect is just how the mathematical relationships work out. There's no flow, no becoming. The entire mathematical structure exists timelessly. Our experience of time, of causation, is how we perceive the structure from inside. Think about a movie. All frames exist on the film. No frame causes another. They're all there, related by continuity. When you watch, you experience flow, causation, time. But that's perception. The film exists all at once. The universe might be the same. All moments exist in the mathematical structure. Past, present, future, all equally real, all parts of the same timeless math. We experience flow because our consciousness moves through the structure, or rather, consciousness is defined moment by moment within the structure. This connects to the block universe idea. Einstein's relativity implies past, present, future all exist. No objective now. Space and time are unified. Events don't happen. They just are, located in space-time. This is deeply mathematical. Space-time is a manifold, a geometric structure existing all at once. Time is a dimension like space. The universe is a four-dimensional mathematical object, not a three-dimensional thing evolving in time. Let me tell you about emergence, because people say complex things emerge from simple math. Water molecules follow simple rules, but wetness emerges. Neurons fire according to physics, but consciousness emerges. So reality is more than math, but that's wrong. Emergence is mathematical. You can, in principle, derive all emergent properties from underlying equations. Wetness is a macroscopic description of molecular behavior. Consciousness, if we understood it, would be derivable from neural dynamics. Emergence doesn't create something beyond math. It's just math at different scales. Here's what disturbs people most. If math creates reality, where does math come from? Who made the math? But that question assumes math needs creation. Math doesn't. Mathematical truths are necessary truths. They couldn't be otherwise. 2 plus 2 equals 4, not because someone decided it, but because that's what those symbols mean. Mathematical structures exist necessarily. They don't need a cause. And if reality is mathematical, reality doesn't need a cause either. It exists necessarily. This solves the ultimate question. Why is there something rather than nothing? Because mathematical structures exist necessarily. Nothing, pure absence, is also a mathematical structure, the empty set. And from the empty set, you can construct all mathematics. Set theory, numbers, geometry, everything builds from nothing through logical necessity. Existence is mathematically inevitable. Let me address the fine-tuning problem. Our universe has specific constants. The electron mass, the gravitational constant, the cosmological constant, these seem arbitrary, finely tuned for life. Why these values? If reality is mathematical, the answer is anthropic. All consistent values exist in different mathematical structures different universes. We find ourselves in one where the constants allow observers, not because it's special, because observers only arise in universes with certain properties. Most mathematical structures are sterile. We're in a fertile one because we couldn't be anywhere else. This is why physics is so mathematical. Physicists often say math is the language of nature, but it's more than language. Language describes, math constitutes. Quarks aren't things described by quantum chromodynamics. Quarks are quantum chromodynamics. They're representations of the SU gauge group. Take away the math, there's no quark left. The math is all there is. People want to know what math is made of, but that's a category error. Math isn't made of anything. Math is fundamental. Asking what math is made of is like asking what existence is made of. Math is the ground floor. It doesn't reduce to something else. Physical stuff that reduces to math. Fields, particles, forces, all mathematical. But math doesn't reduce further. It's the base. Here's an experiment that shows this. Quantum mechanics predicts interference patterns, correlations, entanglement, all from wave functions and operators. These predictions match experiments exactly, but wave functions are mathematical objects living in Hilbert space. They're not physical waves in space, yet they determine what we observe. The math predicts reality perfectly because the math is reality. The wave function isn't representing an electron. The wave function is the electron. Let me tell you about Gödel's incompleteness theorem because it's relevant. Gödel showed any sufficiently complex mathematical system has true statements that can't be proved within that system. Math is inherently incomplete. You might think this means math can't be fundamental, but it actually supports the mathematical universe idea. Reality might be unprovable, undecidable in parts. Quantum mechanics has fundamental randomness. Incompleteness in math might manifest as irreducible uncertainty in physics. Reality inheriting properties from its mathematical nature. Here's the implication for consciousness. If you're a physical being and physical reality is mathematical, then you're mathematical. Your brain states, your thoughts, your sense of self, all mathematical structures. This seems reductive, but it's not. It's expansive. You're not just meat. You're a particular organization of information, and information is mathematical. You're a pattern in the universal computation, and patterns in mathematics are as real as anything gets. What about free will? If reality is mathematical, everything's determined by equations. No room for choice. But determinism isn't incompatible with free will. Your decisions are determined by your brain states, which are physical, which are mathematical. But they're still your decisions. The you making choices is the mathematical structure of your brain processing information. Free will isn't randomness. It's your mathematical structure causing your behavior. That's as free as anything can be. Some physicists push back. They say math is just our best model, not reality itself. There's something underneath, something non-mathematical. But what could that be? Every proposal for what's underneath turns out to be mathematical too. String theory, loop quantum gravity, any attempt to get more fundamental yields more math. At every level, math is what we find. The most economical explanation is there's nothing underneath. Math goes all the way down. Let me give you the final argument. The universe is lawful. Physics works. Same experiments give same results. Laws don't change. This regularity demands explanation. Why are there laws? If reality is mathematical, laws are just relationships within the mathematical structure. They hold because mathematical truths hold necessarily. The universe has laws because it's a mathematical structure, and mathematical structures have internal consistency. Laws of physics are theorems in the mathematics of reality. If reality weren't mathematical, the existence of physical laws would be miraculous. Why should matter obey rules? Why should patterns persist? But if reality is math, laws aren't constraints imposed on matter. Laws are the structure. Matter is patterns obeying laws because matter is mathematical and laws are mathematical relationships. It's all one thing. Here's what this means for physics going forward. We're not trying to find equations that describe reality. We're trying to find what mathematical structure we inhabit. String theory, loop quantum gravity, other approaches, they're searching structure space. The goal isn't better models. It's discovering our location in mathematical existence. Once we know the structure, we know everything. The structure determines all properties, all laws, all phenomena. This changes the game. Instead of asking, why does reality have property X, We ask what mathematical structures have property X, and why do we inhabit one of those structures? Anthropic reasoning becomes physics. Not all mathematics is inhabited by observers. Only certain structures support complexity, information processing, consciousness. We're in one of those because we couldn't observe otherwise. The selection effect is fundamental. Let me address God. If math creates reality, is math God? In a sense, yes. Math is eternal, necessary, omnipresent in reality, the source of all structure and law. But it's not conscious, not personal, not intervening. Math doesn't care. It just is. If you want to call mathematical necessity God, fine. But it's not the God of religion. It's impersonal necessity. The logos, not the Father. What do we do with this knowledge? How do we live knowing we're mathematical structures? Doesn't matter change. You're still experiencing. Suffering still hurts. Joy still feels good. Knowing your math doesn't make experience less real. It makes it more profound. You're part of the fundamental fabric of existence, not a biological accident in a meaningless void. You're a pattern in eternal mathematics. That's beautiful. And it means we can understand everything in principle. If reality is mathematical, and we're good enough at math, we can figure it all out. No mysteries beyond mathematics. Consciousness, quantum mechanics, cosmology, all solvable as math problems. Hard problems, maybe impossible in practice, but not impossible in principle. The universe is comprehensible because it's mathematical and we can do math. Here's my conclusion after 50 years in physics. Math doesn't describe reality. Math creates reality. The universe is a mathematical structure. Space, time, matter, energy, consciousness, all patterns in mathematics. There's no stuff underneath. Math is the stuff, and we're part of it. We're the universe understanding itself through mathematics. Every equation we write, every theorem we prove, we're exploring the structure of existence from inside. We're math studying math. And that's not reductionist. That's the most profound thing I can imagine. Reality is mathematics, not made of mathematics, not described by mathematics, is mathematics. Welcome to the mathematical universe.